The marketing division of an automobile manufacturer thinks that the average income of its customers has increased. The average income of its customers over the past 5 years was $36,445. A random sample of 35 recent customers was drawn. The average income for the sample was $38,935 with a standard deviation of $3,452. A hypothesis test will be conducted at the 0.05 level of significance to determine if the average income of the customers has increased. So we have a sample of 35 with a sample mean of 38,935. And the standard deviation for that sample was 3,452. The average income over the past 5 years was $36,445. So the question is, has the average income increased for this particular automobile manufacturer's clients? So let's take a look at what the hypothesized distribution would look like. Since our sample size is 35, we know that the sampling distribution would be normal. And the hypothesized mean in question is 36,445. And the question is, has this value increased? Well, if our sample mean landed down here to the left somewhere, well, it certainly wouldn't indicate an increase. Remember, what we're trying to do is use a sample to draw a conclusion about a population. And if that sample mean is less than 3645, then we certainly wouldn't have any reason to believe that it's any greater than 36,445. It's if that sample mean lands way up here in the rejection region where it's unlikely that we would have a sample with a mean way up here if the population mean is 36,445. So when we land up here, we will question that the mean is 36,445 and be willing to believe that it's greater. But that is at a certain significance level, and this time that significance level is 0.05. So alpha is 0.05. So our hypotheses then will be the population mean is 36,445, and we would reject that in favor of the alternative hypothesis that the mean is greater than 36,445 if we land up here in this rejection region. We are going to need a critical t-value. We can get that from StatCrunch or a table or the TI-84 calculator, however we would like to. If we use StatCrunch, we'll push stat calculators t. The number of degrees of freedom would be 34 since we had 35 in our sample. This is a one